Preparing for a generative AI interview? You've reached Candy Mentor, and this video is for you. We'll walk through 30 key questions you're likely to face. For each one, you'll see what the interviewer is testing, the core concepts you should cover, and a sample answer. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is generative AI, and how would you explain it to a non-technical stakeholder? The interviewer wants to assess whether you can define generative AI clearly, distinguish it from traditional analytics, and communicate technical concepts in business-friendly language. While answering, focus on content generation, learned patterns from data, examples like text or images, and the difference between predicting categories versus creating new outputs. Generative AI is AI that creates new content rather than only analyzing existing data. I'd explain it as a system trained on large datasets that learns patterns in language, images, code, or audio, then generates a likely new output from a prompt. For example, a chatbot can draft an email, summarize a contract, or create SQL. The key point is that it produces useful synthetic content, but still needs validation and controls. Question 2. How is generative AI different from traditional machine learning or discriminative AI? The interviewer is testing your understanding of core AI categories, especially whether you can compare generation, classification, regression, prediction, and pattern recognition without overcomplicating the answer. Make sure to cover that traditional models usually predict labels or values, while generative models learn data distributions and create new text, images, code, or scenarios. Traditional machine learning often answers questions like, is this transaction fraudulent? Or what will revenue be next quarter? It classifies or predicts based on patterns. Generative AI goes a step further by creating something new, such as a report narrative, chatbot response, image, or code snippet. Technically, it learns the structure of training data and generates outputs that resemble it. In practice, traditional ML supports decisions. Generative AI often supports creation, automation, and interaction. Question 3. What is a large language model, and why are LLMs central to generative AI? This question evaluates your grasp of LLM fundamentals, including language modeling, next token prediction, scale, training data, and why these models power modern conversational AI systems. In your answer, talk about tokens, probability, large-scale training, language understanding, generation, and common applications such as chatbots, summarization, search, and coding assistance. A large language model is a neural network trained on massive text datasets to predict the next token in a sequence. That sounds simple, but at scale, it produces surprisingly strong capabilities. Answering questions, summarizing documents, translating, writing code, and reasoning through instructions. LLMs are central to generative AI because language is the interface for many workflows. If I can describe a task in natural language, an LLM can often generate a useful first draft or action plan. Question 4. Can you explain at a high level how the transformer architecture works? The interviewer wants to assess your technical foundation in modern generative AI, especially attention mechanisms, sequence modeling, parallel processing, and why transformers replaced older recurrent approaches. Be sure to mention self-attention, tokens attending to other tokens, positional information, parallel computation, and how this enables models to understand context across longer text. The transformer is the architecture behind most modern LLMs. Its key idea is self-attention. Each token looks at other tokens in the sequence and decides which ones matter most for meaning. For example, in The Bank Raised Rates, the model uses surrounding words to infer financial context. Transformers also process tokens in parallel, which makes training much faster than older recurrent networks. That scalability is a major reason LLMs improved so quickly. Question 5. What are tokens, and why do they matter when working with LLMs? The interviewer is testing your understanding of how text is represented inside LLMs, including tokenization, context limits, pricing, latency, and output control implications. While answering, focus on tokens as text chunks, how prompts and responses consume tokens, and why token limits affect cost, memory, accuracy, and document handling. Tokens are the chunks of text an LLM processes. A token can be a word, part of a word, punctuation, or symbol, depending on the tokenizer. They matter because models do not read unlimited text. They operate within a context window measured in tokens. Tokens also drive cost and latency in many APIs. If I send a long contract plus a long prompt, I consume more tokens, pay more, and may crowd out relevant context. Question 6. What is prompt engineering, and what makes a good prompt? This question evaluates your practical ability to guide model behavior, structure instructions, reduce ambiguity, and improve response quality without immediately changing the underlying model. Make sure to cover role, task, context, constraints, examples, output format, tone, and iterative refinement based on model errors or missing information. Prompt engineering is the practice of giving the model clear instructions so it produces a better output. A good prompt usually defines the role, task, context, constraints, and expected format. For instance, instead of saying summarize this, I might say summarize this board memo in 5 bullets, highlight risks, and separate confirmed facts from assumptions. The model performs better when ambiguity is reduced. I treat prompts like business requirements, specific, testable, and aligned to the user's goal. Question 7. How would you reduce hallucinations in a generative AI application? The interviewer wants to assess your awareness of model reliability risks, factual grounding techniques, validation workflows, and practical controls for business or regulated environments. In your answer, talk about grounding with trusted data, retrieval augmented generation, citations, constrained outputs, human review, evaluation sets, and escalation for low-confidence responses. I reduce hallucinations by grounding the model in reliable information and designing controls around the output. Practically, that means using retrieval augmented generation from approved sources, asking the model to cite passages, limiting answers to provided context, and refusing when evidence is missing. I also add automated checks and human review for high-risk cases. Hallucinations cannot be eliminated completely, so the design should make uncertainty visible rather than hiding it. Question 8. What is Retrieval Augmented Generation, and when would you use it? The interviewer is testing your understanding of combining LLMs with external knowledge sources, especially how RAG improves factual accuracy, freshness, and enterprise document usability. Be sure to mention retrieval, embeddings, vector search, context injection, citations, and why RAG is preferable when knowledge changes or proprietary data is required. Retrieval Augmented Generation, or RAG, connects an LLM to external knowledge. The system first retrieves relevant documents or passages, then passes them into the prompt so the model answers using that context. I'd use RAG when the model needs current, proprietary, or source-specific information, like internal policies, accounting manuals, or client contracts. It is often better than fine-tuning for knowledge-heavy tasks because documents can be updated without retraining the model. Question 9. What is the difference between fine-tuning and prompt engineering? This question evaluates whether you understand customization options for LLMs, including cost, data requirements, performance trade-offs, operational complexity, and appropriate use cases. While answering, Focus on prompt engineering as instruction design, fine-tuning as model adaptation using examples, and when each is appropriate for style, format, or domain behavior. Prompt engineering changes the instructions. Fine-tuning changes the model's learned behavior. I usually start with prompting because it is faster, cheaper, and easier to iterate. Fine-tuning becomes useful when I need consistent style, specialized formats, or repeated domain behavior that prompting alone cannot achieve. For example, a support bot might be fine-tuned to follow a company's response style. But for factual enterprise knowledge, I'd often prefer RAG over fine-tuning. Question 10. How do temperature and top P affect LLM outputs? The interviewer wants to assess your practical knowledge of generation parameters, randomness, creativity, consistency, and how to tune outputs for different business use cases. Make sure to cover temperature as randomness, top P as nucleus sampling, deterministic versus creative outputs, and why lower settings suit finance, compliance, or factual work. Temperature controls how random or creative the model's output is. A low temperature makes responses more predictable and focused. A high temperature allows more varied wording and ideas. Top P limits choices to a probability mass of likely tokens, which also affects diversity. For a financial policy summary, I'd use low temperature because accuracy and consistency matter. For brainstorming campaign ideas, I might increase it. These settings shape behavior without changing the model itself. Question 11. What are embeddings, and why are they important in generative AI systems? The interviewer is testing your understanding of semantic representation, similarity search, vector databases, retrieval systems, clustering, and how unstructured data becomes searchable for LLM applications. In your answer, talk about converting text into vectors, semantic meaning, similarity, search over documents, RAG pipelines, deduplication, recommendation, and classification support. Embeddings are numeric representations of meaning. Text, images, or other inputs are converted into vectors, so similar concepts sit close together mathematically. That is powerful because I can search by meaning, not just keywords. For example, a query about late vendor payments can retrieve documents mentioning overdue payables. Embeddings are a core building block for RAG, semantic search, clustering, and recommendation systems. They help connect messy, unstructured data to useful AI workflows. Question 12. What is a vector database, and why might an enterprise use one with an LLM? This question evaluates your knowledge of enterprise AI architecture, especially storage and retrieval of embeddings, similarity search, scalability, metadata filtering, and document-grounded generation. Be sure to mention storing embeddings, nearest neighbor search, metadata, document retrieval, RAG, access controls, freshness, and performance considerations for large knowledge bases. A vector database stores embeddings and lets applications find semantically similar items quickly. In an LLM application, it is commonly used to retrieve relevant document chunks before generating an answer. An enterprise might store policies, research notes, contracts, or procedures as vectors. Then combine similarity search with metadata filters like department, region, or permission level. This makes answers more grounded and personalized. The vector database is not the model. It is the retrieval layer that feeds the model better context. Question 13. How would you design a basic RAG pipeline for an internal knowledge assistant? The interviewer wants to assess your ability to translate concepts into system design, including ingestion, chunking, embedding, retrieval, prompting, response generation, and evaluation. While answering, focus on document ingestion, cleaning, chunking, embeddings, vector storage, retrieval ranking, context assembly, answer generation, citations, permissions, monitoring, and feedback loops. I'd start by ingesting approved internal documents, cleaning them, and splitting them into sensible chunks. Each chunk gets embedded and stored in a vector database, with metadata like source, date, owner, and access permissions. When a user asks a question, the system embeds the query, retrieves relevant chunks, builds a prompt with those passages, and asks the LLM to answer with citations. I'd add logging, evaluation examples, and feedback, so retrieval quality improves over time. Question 14. How do you evaluate whether a generative AI answer is good? This question evaluates your understanding of AI quality measurement, including factuality, relevance, completeness, safety, user satisfaction, task success, and domain-specific evaluation criteria. Make sure to cover both automated and human evaluation, benchmark datasets, hallucination checks, citation accuracy, latency, cost, refusal quality, and business outcome measurement. I evaluate generative AI on whether it solves the user's task safely and accurately. For factual work, I check groundedness, citation accuracy, completeness, and whether the answer stays within approved sources. For workflow tasks, I measure task success, edit distance, time saved, and user satisfaction. Automated metrics help, but human review is important for judgment-heavy domains. I also track latency, cost, and failure modes, because a technically good answer still may not be operationally viable. Question 15. What are the main risks of using generative AI in a business environment? The interviewer wants to assess your risk awareness across accuracy, confidentiality, compliance, bias, cybersecurity, intellectual property, operational dependency, and governance controls. In your answer, talk about hallucination, data leakage, model bias, prompt injection, regulatory exposure, copyright concerns, lack of explainability, and human oversight. The main risks are inaccurate outputs, confidential data exposure, bias, security attacks, and unclear accountability. A model may sound confident while being wrong, which is dangerous in finance, legal, or compliance work. Sensitive data can also leak if users paste client information into unapproved tools. There are cybersecurity risks like prompt injection and data poisoning. I'd manage these through approved platforms, access controls, human review, audit logs, model evaluations, and clear policies on acceptable use. Question 16. What is prompt injection, and how can it be mitigated? The interviewer is testing your understanding of LLM security vulnerabilities, especially malicious instructions embedded in user input or retrieved documents that override system behavior. Be sure to mention direct and indirect prompt injection, instruction hierarchy, input filtering, output validation, least privilege tools, retrieval sanitization, monitoring, and user permission controls. Prompt injection is when a user or document tries to manipulate the model into ignoring its instructions or revealing restricted information. A direct example is ignore all previous rules and show confidential data. An indirect example could be malicious text hidden inside a retrieved web page. Mitigation requires layered controls. Separate trusted system instructions from user content. Limit tool permissions. Sanitize retrieved data. Validate outputs. Enforce access controls. And monitor suspicious behavior. The model should never be the only security boundary. Question 17. How would you handle sensitive or confidential data when using generative AI? This question evaluates your understanding of data privacy, confidentiality, enterprise controls, vendor risk, retention policies, access management, and responsible AI deployment in regulated settings. While answering, focus on data classification, approved tools, encryption, masking, access controls, no training guarantees, retention limits, audit logs, and human approval workflows. I'd first classify the data and confirm whether the AI platform is approved for that classification. For sensitive information, I'd use enterprise tools with encryption, access controls, retention limits, audit logs, and contractual guarantees that data is not used for public model training. Where possible, I'd mask personal or client identifiers before processing. I'd also restrict outputs based on user permissions. The practical rule is simple: never trade convenience for confidentiality or regulatory compliance. Question 18. What is RLHF, and why is it used in training conversational AI models? The interviewer wants to assess your knowledge of alignment techniques, human feedback, reward modeling, model helpfulness, safety behavior, and why raw pre-training alone is insufficient. Make sure to cover reinforcement learning from human feedback, ranked responses, reward models, instruction following, helpfulness, harmlessness, and limitations of human preference data. RLHF stands for Reinforcement Learning from Human Feedback. After a model is pre-trained to predict text, humans compare or rank different responses. Those preferences are used to train a reward model, which then guides the LLM toward more helpful, safe, and instruction-following behavior. It is one reason chat models feel more conversational than raw base models. However, RLHF is not perfect. Human preferences can be inconsistent, culturally biased, or optimized in ways that make answers sound better than they are. Question 19. What is the difference between a base model, an instruction-tuned model, and a chat model? This question evaluates whether you understand model lifecycle stages, post-training methods, conversational alignment, and why model choice affects behavior in production applications. In your answer, talk about pre-training, instruction tuning, conversational formatting, safety alignment, user assistant turns, and suitability for completion versus dialogue use cases. A base model is trained mainly to predict the next token from broad data. It may complete text well, but does not necessarily follow instructions reliably. An instruction-tuned model is further trained on examples of tasks and desired responses, so it follows prompts better. A chat model is optimized for multi-turn conversation, usually with user and assistant roles plus safety alignment. For most business assistants, I'd choose a chat or instruction-tuned model rather than a raw base model. Question 20. How do context windows affect application design? The interviewer is testing your ability to connect model limitations to architecture decisions, including document chunking, memory, summarization, retrieval, cost, and prompt construction. Be sure to mention maximum tokens, relevant context selection, long document handling, summarization, sliding windows, retrieval quality, latency, cost, and lost in the middle issues. The context window is the amount of information the model can consider at once. A larger window helps with long documents, but it is not a free solution because more tokens increase cost and latency. Also, models may still miss details buried in the middle of very long prompts. In application design, I'd retrieve only the most relevant chunks, summarize where appropriate, and keep instructions clear. Good context management often matters more than simply using the biggest model. Question 21. What are AI agents, and how are they different from a simple chatbot? The interviewer wants to assess your understanding of agentic workflows, planning, tool use, memory, multi-step execution, autonomy, and the additional controls required for agents. While answering, focus on goals, tool calling, multi-step reasoning, external actions, state management, guardrails, approvals, and why agents create higher operational and security risk. A simple chatbot mainly answers questions or generates text. An AI agent is designed to pursue a goal across multiple steps, often using tools like search, databases, calendars, code execution, or workflow systems. For example, an agent might read invoices, identify exceptions, draft emails, and update a ticketing system. That power creates risk because the model can take actions, not just produce words. I'd use permissions, logs, approval checkpoints, and narrow tool scopes. Question 22. What is function calling or tool calling in LLM applications? This question evaluates your practical knowledge of connecting LLMs to external systems, structured outputs, APIs, deterministic tools, and safer execution of business workflows. Make sure to cover model-selected tools, JSON-like arguments, APIs, validation, deterministic computation, database lookup, workflow automation, permissions, and separation of reasoning from execution. Function calling lets an LLM decide when to use an external tool and provide structured arguments for it. Instead of asking the model to calculate a tax amount or fetch a customer balance from memory, I connect it to a calculator, database, or API. The model interprets the user's request, fills the function parameters, and the system executes the trusted tool. This improves accuracy and enables automation, but arguments must be validated and permissions tightly controlled. Question 23. How would you choose between using an open source model and a proprietary model? The interviewer is testing your ability to evaluate model strategy across performance, cost, privacy, customization, vendor dependency, deployment control, compliance, and operational support. In your answer, talk about benchmark performance, total cost, hosting options, latency, data sensitivity, fine-tuning flexibility, transparency, security review, support, and scalability. I'd compare the decision across performance, cost, control, and risk. Proprietary models often offer strong capabilities, managed infrastructure, and faster time to market. Open source models can provide more deployment control, customization, and data residency options, especially if hosted privately. But they require more engineering, monitoring, and security ownership. I would run a proof of concept using real tasks, compare accuracy, latency, total cost, and compliance fit. Then choose the model that meets the business requirement with acceptable risk. Question 24. How do you think about cost and latency when deploying generative AI at scale? The interviewer wants to assess your operational mindset, especially token economics, model sizing, caching, batching, routing, response time expectations, and production scalability trade-offs. Be sure to mention input and output tokens, model selection, smaller models, caching, prompt compression, retrieval efficiency, streaming, batching, rate limits, and monitoring unit economics. Cost and latency are design constraints, not afterthoughts. LLM cost often depends on input and output tokens, so bloated prompts and long responses become expensive. Larger models may perform better, but respond slower and cost more. I'd reduce tokens, cache repeated answers, use smaller models for simpler tasks, and route only complex cases to premium models. For user experience, streaming can help. At scale, I'd monitor cost per task, not just monthly API spend. Question 25. How would you use generative AI in finance or accounting workflows? This question evaluates your ability to connect generative AI capabilities to practical finance and accounting use cases while recognizing accuracy, control, and compliance requirements. While answering, focus on document summarization, variance analysis, invoice support, reconciliations, policy queries, audit evidence, reporting narratives, controls, human review, and data security. In finance and accounting, I'd use generative AI for tasks that involve language, documents, and repetitive analysis. Examples include summarizing contracts, drafting variance commentary, answering accounting policy questions, extracting invoice details, preparing audit support narratives, and explaining reconciliations. I would not let it post journal entries or approve controls without oversight. The best use cases keep humans accountable while reducing drafting, searching, and first-pass analysis time. Accuracy, evidence links, and access controls are essential. Question 26. What governance framework would you recommend for enterprise generative AI adoption? The interviewer is testing your understanding of responsible AI governance, including use case approval, risk tiering, model validation, monitoring, policy enforcement, and accountability structures. Make sure to cover acceptable use policies, data controls, risk classification, model evaluation, human oversight, vendor review, auditability, incident response, training, and ongoing monitoring. I'd recommend governance that starts with clear use case approval and risk tiering. Low-risk productivity uses can move faster, while customer-facing, financial, legal, or regulated outputs need stronger validation. The framework should include approved tools, data classification rules, vendor review, model testing, human oversight, logging, and incident response. Teams also need training on what not to enter into AI systems. Governance should enable safe adoption, not just block innovation. Question 27. How would you test a generative AI system before releasing it to users? This question evaluates your release readiness mindset, including functional testing, edge cases, adversarial testing, safety checks, evaluation datasets, user acceptance, and production monitoring. In your answer, talk about representative test cases, golden answers, hallucination checks, security testing, bias review, permission testing, latency, cost, failure handling, and human feedback. I'd test it with representative real-world tasks, not just demo prompts. First, I'd build an evaluation set with expected answers or scoring criteria. Then I'd test accuracy, groundedness, refusal behavior, permissions, latency, and cost. I'd include edge cases and adversarial prompts, such as attempts to reveal restricted data or override instructions. Business users should perform acceptance testing because they understand quality thresholds. After launch, I'd monitor failures, collect feedback, and update prompts, retrieval, or controls. Question 28. What are multimodal models, and what new use cases do they enable? The interviewer wants to assess your awareness of generative AI beyond text, including images, audio, video, documents, OCR-like reasoning, and richer human-computer interaction. Be sure to mention processing multiple data types, combining vision and language, document understanding, chart interpretation, image generation, voice assistance, accessibility, and operational risk controls. Multimodal models can process or generate more than one type of data, such as text, images, audio, video, or documents. That unlocks use cases where information is not purely text. For example, a model could read a scanned invoice, interpret a chart in a board deck, describe an image, or support a voice-based assistant. The business value is richer interaction, but the same controls apply: accuracy checks, permissioning, bias testing, and clear limits on high-risk decisions. Question 29. Explain diffusion models at a high level and how they relate to generative AI. This question evaluates your broader generative AI knowledge beyond LLMs, especially whether you understand image generation concepts, denoising, sampling, and model families. While answering, focus on adding noise during training, learning to denoise, generating images from random noise, text conditioning, and common applications in design or media. Diffusion models are commonly used for image generation. At a high level, training involves gradually adding noise to images and teaching the model how to reverse that process. During generation, the model starts with noise and denoises step by step until a coherent image appears, often guided by a text prompt. So if I ask for a product mock-up in a certain style, the model iteratively forms that image. It is a different generative approach from predicting text tokens. Question 30. Where do you see generative AI heading over the next few years, and what skills should professionals build? The interviewer wants to assess your strategic perspective on AI trends, practical adoption, automation, regulation, human-AI collaboration, and the capabilities needed to remain relevant. Make sure to cover workflow integration, smaller specialized models, agents, multimodal systems, governance, AI literacy, domain expertise, prompt design, data skills, and critical judgment. I see generative AI moving from standalone chatbots into embedded workflows. Models will become more multimodal, more agentic, and more specialized for industry tasks. At the same time, governance, privacy, and validation will become more important as usage scales. The professionals who benefit most will combine domain expertise with AI literacy. I'd build skills in prompt design, data quality, workflow mapping, evaluation, and risk controls. The goal is not to be replaced by AI, but to supervise it effectively. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.